Chapter 4, Carbon Compounds. Now let us start the session with introduction to carbon compounds. At the end of this session, you will be able to understand about what is carbon, occurrence of carbon, carbon compounds, and applications of carbon compounds. What is carbon? Carbon is a non-metallic element, and it is denoted by the letter C. The name carbon is derived from the Latin word carbo, which means coal. Carbon is in solid state. The melting point of carbon is 3500 degrees Celsius, and the boiling point is 4827 degrees Celsius. The atomic mass of carbon is 12 amu, and its atomic number is 6. Carbon is present in 14th group, second period, and it is a p-block element in the periodic table. Now, let us move on to the pictorial representation of carbon in modern periodic table. Here, in the periodic table you can see, the highlighted one in animation, which is located at 14th group, is said to be carbon element. Let us discuss about the atomic structure of carbon. The carbon atom has 6 electrons. 4 of the electrons are in its valence shell, that is, the outer shell. We can see circles representing the energy levels. We can see carbon has 6 electrons represented by arrows. 2 electrons are found in the 1s orbital, and the next 2 will go into the 2s orbital. The remaining 2 electrons are arranged in 2 separate 2p orbitals. This is because the p orbitals have same energy, and the electrons would rather be in separate orbitals. The images shows the carbon energy levels of 2s, 2px, and 2py orbitals. Let us discuss about the atomic structure of carbon. Here the diagram shows the increasing energy levels represented with an up arrow. We know that carbon atom has 6 electrons represented by X symbol. First 2 electrons are placed in the 1s orbital, close to the nucleus. The next 2 electrons are placed in the 2s orbital. The remaining electrons will be in 2 separate 2p orbitals. This is because the p orbitals have the same energy. To know about the structure of carbon, first we need to know about the structure of an atom. The structure of an atom is based upon component parts of an element. A unique chemical substance, found in nature, that is made up of specific, identical atoms is said to be an element. Example of an element is carbon. An atom is made up of protons, neutrons, and electrons. Protons are the smallest positively charged unit of matter. Neutrons are the smallest neutral unit of matter, that is, no charge. Electrons are the smallest negatively charged unit of matter. The structure of each atom has a ball-shaped center, called the nucleus, which contains the protons and the neutrons. Around this nucleus the electrons orbit, like planets around the sun. Let us note that each element of an atom has an equal number of protons and electrons, but neutrons may vary, and is calculated by the formula neutrons N equals atomic mass unit amu minus atomic number Z. Let us see the general atomic structure of electrons in energy levels. The subshell S, which is spherical in shape, has 1 orbital and contains maximum of 2 electrons. The subshell P, which is dumbbell in shape, has 3 orbitals and contains maximum of 6 electrons. The subshell D, which is X-shaped, has 5 orbitals and contains maximum of 10 electrons. The subshell F, which is complex in shape, has 7 orbitals and contains maximum of 14 electrons. Now, let us move to the carbon in nature. Carbon in nature. Carbon is the 4th most abundant element in the universe, and it plays a crucial role in the health and stability of our planet. Carbon is a naturally abundant non-metallic element, which forms the basis of most living organisms. In general, carbon is released from ecosystems as carbon dioxide gas by the process of respiration. Plants take carbon dioxide and gives oxygen during the process of photosynthesis. In this way, human interaction starts with carbon and its compounds.